मालवीय मिशन टीचर्स ट्रेनिंग सेंटर रानी दुर्गावती विश्वविद्यालय में मैं आप सभी प्रतिभागियों का स्वागत करता हूं रिफ्रेशर कोर्स बेसिक साइंस में। जैसा कि आप सभी जानते हैं कि यह कोर्स 19 तारीख से लेकर 31 तारीख के लिए शेड्यूल हुआ है, जिसमें 19 तारीख को रक्षाबंधन के अवकाश के कारण इसको आज 20 तारीख से प्रारंभ किया गया एवं कल के स्थान पे 25 तारीख रविवार को भी आपकी क्लासेस रहेंगी। तो इस प्रकार हम 12 दिन का ये कार्यक्रम पूरा कर पाएंगे। मैं अपने इस कार्यक्रम में हमारे मालवीय मिशन टीचर्स ट्रेनिंग सेंटर के डायरेक्टर प्रोफेसर एस संधू सर का स्वागत करता हूं। प्रोफेसर एस संधू एक अंतर्राष्ट्रीय स्तर के जाने माने वैज्ञानिक हैं और आप यहाँ के डीआईसी के भी डायरेक्टर हैं, साथ ही डिपार्टमेंट ऑफ बायोसाइंस रानी दुर्गावती विश्वविद्यालय के हेड ऑफ द डिपार्टमेंट हैं। प्रोफेसर संधू रिसर्च के क्षेत्र में आप गूगल करके इनके बारे में काफी कुछ जान सकते हैं। आप हमारी रानी दुर्गावती विश्वविद्यालय के एक प्रकार के रत्न हैं। आपके द्वारा रानी दुर्गावती विश्वविद्यालय के डिपार्टमेंट के द्वारा बहुत सारे पेटेंट आपके नाम से है, बहुत सारे अच्छे रिसर्चेस आपके नाम से हैं। आप हमारे विश्वविद्यालय के नैक टीम के साथ ही कई कोर कमिटीज के आप मेंबर हैं। हम यहाँ के कई महाविद्यालयों के गवर्निंग बॉडी के आप मेंबर हैं। आप एज ए डायरेक्टर आप पीपल्स ग्रुप के में भी आप कार्य कर चुके हैं और मैं मुख्य रूप से यह कहना चाहूँगा कि आप एक अच्छे साइंटिस्ट हैं और साइंटिस्ट एक दार्शनिक भी होते हैं और आपका स्वभाव, आपके मृदुल भाषा और आप जिस तरीके से अपने रिसर्च स्कॉलर्स और हम सभी लोगों को एक पारिवारिक रिश्ते के तरीके से करते हैं, इसलिए हम सब आपके काफी साथ में काम करने के इच्छुक रखते हैं और हमें बहुत अच्छा लगता है। मैं आपका स्वागत करता हूं सर।
धन्यवाद।
आज हमारे बीच इस कोर्स के में जो कोऑर्डिनेट कर रहे हैं, इस कोर्स के कोऑर्डिनेटर हैं प्रोफेसर आर.एस. चंडोक सर। आप गुरु तेग बहादुर खालसा कॉलेज के आप प्रिंसिपल हैं। आप बेसिकली फिजिक्स के प्रोफेसर हैं और आपने अपनी शिक्षा इसी रानी दुर्गावती विश्वविद्यालय से पूर्ण की है और बहुत बड़े साइंटिस्टों के साथ आपने रिसर्च का कार्य किया हुआ है और आप इस समय फिजिक्स के क्षेत्र में और स्पिरिचुअलिटी के क्षेत्र में आपके बहुत अच्छे काम हैं। क्वांटम फिजिक्स वगैरह के आप बड़े ज्ञाता हैं। आपके कई शोध पत्र और कई सेमिनार में आपके जो लेक्चर्स होते हैं, आप हमारे कोर्सेज के भी रिसोर्स पर्सन हैं। कई बड़ी बड़ी संस्थाओं में आपके व्याख्यान के लिए आप आमंत्रित किए जाते हैं। मैं प्रोफेसर चंडोक सर का हृदय से स्वागत करता हूं मालवीय मिशन ट्रेनिंग सेंटर।
वेलकम सर, वेलकम।
ये पूरा प्रोग्राम चंडोक सर के निगरानी में पूरा होगा। सभी रिसोर्स पर्सन से आपने बात की है और बहुत अच्छे तरीके से आपने मेरे को आज शाम तक हम लोग इस वीक का पूरा टाइम टेबल अपने प्रतिभागियों को दे देंगे और काफी व्यस्ततम समय में कॉलेज को संभालने के साथ साथ आपका बाहरी काम को भी देखना पड़ता है। कल आप बाहर थे पर वहां रहते हुए भी आपने रिसोर्स पर्सन्स और इस प्रोग्राम को कोऑर्डिनेट करने में बड़ी भूमिका निभाई। चंदोक सर, आपका स्वागत है।
सर नमस्कार करता हूं।
इस स्वागत समारोह में प्रोफेसर संधू सर से निवेदन करूंगा। इसके पहले मैं चाहूंगा कि चंदोक सर इस प्रोग्राम के बारे में, इसमें क्या क्या होने वाला है, इससे संबंधित अपनी बातें रखें। ओवर टू यू चंदोक सर।
Very good morning to one and all. Myself, Dr. R.S. Chandok, Principal Shri Guru Tegh Bahadur Khalsa College, Jabalpur, and course coordinator of 2-week online refresher course organized by Madan Mohan Malviya Mission Training Center of Rani Durgavati University, Jabalpur. First of all, I am grateful to our Honorable Dynamic Kulguru, Professor Rajesh Verma ji, respected Professor S.S. Sandhu ji, Director, Madan Mohan Training Center, and Professor Sanjeev Pandey ji, Assistant Director, Jabalpur, to providing me this opportunity. I welcome all the participants in this 2-week online refresher course from 20th August to 31st August who are attending this program from different states of India. As we know, science today is progressing at a fast pace. Teachers of colleges have to be in start of art in various science disciplines. This training program is conducted in basic science aimed at capacity building of teacher community. The primary focus is to enhance the quality of science education at graduate and postgraduate level, which will help teachers to aid the value in their teaching. As per the new education policy 2020, a teacher has to guide the student in various fields of science like botany, zoology, biotech, microbiology, physics, chemistry, mathematics, etc. In this series of lecture by experts from various institutes of all over India like NPL, National Physical Laboratory, DRDO, NTPC, IIITDM, Regional Institute Bhopal, Ravi Shankar Shukla University, Raipur, Barkatullah University Bhopal, Mangalatayan University Jabalpur, Nagpur University, IIT Hyderabad, Dr. C.V. Raman University Bilaspur, Punjab University, Bhoj University Bhopal, ICMR, Acharya Nagarjuna University Andhra Pradesh, University Hyderabad, etc. The respected professor will deliver their lecture which will enhance your knowledge. I hope you will enjoy this 2-week program and continuous assessment. All the best and thank you all. Deliver to Sanjeev Pandey, sir.
थैंक यू चंडोक सर। मैं संधू सर से निवेदन करूंगा कि वे अपने स्वागत।
Thank you very much, Dr. Sanjeev Pandey. At the outset, I am also thankful to Honorable Vice Chancellor Professor R.K. Verma sir, Rani Durgavati University Jabalpur, and our Registrar Dr. Dipesh Mishra ji. I'm thankful to Dr. R.S. Chandok Saab, Principal SGTB Khalsa College, for accepting our invitations to coordinate this function. It's very difficult actually. Science coordination is very difficult because scientists are damn busy in the life and they don't have time for sparing to coming for the lectures and going here and there because they have got a lot of projects themselves. But he accepted it, and not only accepted, and like he was mentioning that he has called from DRDO, IIITDM, IIT Hyderabad, the great scientists all over the India he has invited. And I'm sure his expertise and his connections is going to help our MM-TTC refresher workshop, refresher courses. And as far as I know, Dr. Chandok is a very versatile person, and he has written many books, I'm telling you. If you count them, the royalty he's getting is more than 2 lakh rupees for the books. So this is what is needed for a scientist. What happens, you know, scientists are just begging the grant from here and there कि सर हमें प्रोजेक्ट मिल जाए, और डॉक्टर चंडोक ने सारी जिंदगी की ग्रांट हासिल कर ली है कि इतनी सारी लेख पुस्तिकाएं और पेपर्स और पेटेंट्स कर लिए हैं कि आपको कंटिन्यूसली ये प्रोजेक्ट रॉयल्टी के हिसाब से इनको प्रोजेक्ट की जो कंटीजेंसी जैसी मिलती है जिससे और आगे बढ़ते चले जा रहे हैं. दैट्स अ वंडरफुल थिंग, हमें सोचना चाहिए. और अभी डॉक्टर चंडोक ने एक डॉक्टर मिस्टर उगे से हमने हमारा मुलाकात करवाई, वो भी लेकर आ रहे हैं, वो भी ही इज आई थिंक पार्ट ऑफ दिस रिफ्रेशर कोर्स आल्सो. और उन्होंने ये बताया कि आप जो भी सोच के लिखते हैं, इवन 4 पेज या 5 पेज भी जो लिखते हैं, इनका कॉपी राइट भी रजिस्टर्ड करा सकते हैं आप आईपीआर में, और उस आईपीआर के बाद वो आपकी प्रॉपर्टी हो जाएगी. एंड देन यू सी सो मेनी कॉपीराइट्स एंड सो मेनी थिंग्स आर गोइंग टू गिव यू लॉट ऑफ मनी. मतलब आप काम करते रहिए, लक्ष्मी जी सरस्वती जी की पूजा करिए, लक्ष्मी जी आपके पीछे पीछे आएंगी. ये हमारे चंडोक जी ने करके दिखाया है. बहुत ही शानदार। आपको सीखना चाहिए सबको कि चंडोक साहब ने जिस प्रकार से कोरोना के टाइम इन्होंने पूरे कॉलेज को घर में बैठे बैठे ऐसा एंगेज किया कि हर कॉलेज के हर टीचर की एक एक दो दो किताबें भी आई हैं। उनको बोला कि आप जो नोट्स बना रहे हो उनको इसको चैलेंज के जैसे लीजिए कोरोना को, और इन्होंने करीब करीब 60-65 तो किताबें उस टाइम लिख डाली हैं। लोग यहाँ पे तारीफ करते हैं कि देखो कोरोना आया था, बुरा टाइम था, लेकिन बुरे टाइम को भी सर ने यूज करते हुए, इस प्रकार से वैज्ञानिकों को मोटिवेट करते हुए बहुत कुछ काम किया है। मैं बताना चाहूंगा कि हमारे मालविया मिशन टीचर्स ट्रेनिंग सेंटर में ये भारतवर्ष का 5वें रैंक का HRDC का सेंटर है। पूरे भारतवर्ष में करीब 180 खुल चुके हैं MMTTC और HRDC, और जो ये ट्रेनिंग सेंटर्स हैं ये 180 हो चुके हैं टोटल आज की डेट में, और उसमें हमारा जो जबलपुर का है वो 5वें स्थान पे आता है। और आपको खुशखबरी और बताऊंगा आपको, ये हमारे जो ऑनरेबल वाइस चांसलर R.K. वर्मा साहब हैं, इनके निर्देशन में, इनकी निगरानी में अभी हमें A ग्रेड का नेक का हासिल हुआ है, और ये बहुत हमारे लिए गौरव की बात है कि आपकी अब MMTC A ग्रेड यूनिवर्सिटी को बिलोंग करता है, तो आपके यहाँ भी नेक होती है। आप देखेंगे ये सारी चीजें आपको नेक में काम आती हैं। और डॉक्टर चंडोक ने इतनी मदद करी है हमें नेक के दौरान, अपने कंप्यूटर्स के लिए, अपने बुक्स के लिए, अपने स्टाफ के लिए पूरा इन्होंने हमारे को सपोर्ट दिया है, जिसकी वजह से आज हम A ग्रेड में पहुंचे हैं। और दूसरा बताना चाहूंगा मैं कि जैसे NEP आ गया है। अब NEP में ये कहा जाता है कि आपको नई शिक्षा जो नीति आई है, राष्ट्रीय शिक्षा नीति 2020, इसमें आपको ये कहा गया है कि आपकी पहली यूनिट जो होगी, पहली यूनिट इंडिजिनस या इंडियन नॉलेज सिस्टम के ऊपर बेस होनी चाहिए। और मैं आपको बताऊं, वहां पे हम बहुत लोग फेल हो रहे थे। हम लोग को साइंस पढ़ना पूरा याद है, हमें आर्किमिडीज का सिद्धांत याद है, हमें सारी चीजें याद हैं, लेकिन उससे पहले क्या हुआ होगा इस देश के अंदर, इस भारतवर्ष के अंदर, उसका ज्ञान नालंदा जैसे विश्वविद्यालयों में जला के खाक कर दिया गया, और हम वंचित रह गए हमारे एजुकेशन सिस्टम में लाने के लिए। अब नई शिक्षा नीति के तहत आपको इंडियन नॉलेज सिस्टम के अंतर्गत आपका ज्ञान जो आपके पास था, संस्कृत में हो, गुरु ग्रंथ साहब में हो, गीता में हो, रामायण में हो, जहां जहां ज्ञान था, जहां जहां विज्ञान थी, उसका रेफरेंस देते हुए आपको यूनिट नंबर 1 में वो नए सिलेबस बनाने पड़ेंगे। और मैं आपको बताते हुए मुझे बड़ी खुशी हो रही है कि अभी अभी हमारे यहाँ कॉन्फ्रेंस, नेशनल कॉन्फ्रेंस हुई थी, जो कि फिजिक्स के लिए हुई थी। उसमें हमारे प्रोफेसर चंडोक साहब का जो भाषण था, और जो उन्होंने क्वांटम फिजिक्स को रिलेट किया रिलीजन्स के साथ, और एक एक प्रूफ के साथ जो चीज की, उसके लिए जो हमारे विशेषज्ञ आए थे बहुत खुश होकर गए हैं, और सर का नाम नोट करके लेके गए हैं कि सर को कोर कमेटी में भी हम लोग रखेंगे, क्योंकि सर ने बहुत अच्छा उस दिन व्याख्यान दिया। और उनकी नॉलेज जो है वो आप शेयर करोगे, आप जब लेक्चर सुनोगे उनका क्वांटम फिजिक्स के ऊपर, आपको लगेगा कि अरे बाप रे, फिजिक्स इतना टफ सब्जेक्ट था और कितना प्यारा हमारे धर्म के साथ जोड़ते हुए प्रोफेसर चंडोक ने प्रेजेंट किया। यही जरूरत है हमारे एनईबी के साथ साथ में, बॉटनी में भी, केमिस्ट्री में भी, बायोकेमिस्ट्री में भी, और जितने भी हमारे केमिस्ट्री की है, मैथमेटिक्स है, इस सब के अंदर भी हमें, जैसे जो हमारे यहाँ भारतवर्ष का ज्ञान था, उनको ऑथेंटिक रूप में हमारे वेदों का रेफरेंस देते हुए हमें उसको पेंशन करना पड़ेगा। तो ये एक बहुत बड़ा कदम है मालविया मिशन टीचर ट्रेनिंग सेंटर का, कि हम एनईपी के लिए ये रिफ्रेशर्स कोर्स जो कर रहे हैं, वो एनईपी में आप लोग अपने अपने कॉलेजेस में नए सिलेबस में 20% यूजीसी के सिलेबस में चेंज करते हुए, हमेशा 20% आप चेंज कर सकते हो बोर्ड ऑफ स्टडीज में, उसमें चेंज करते हुए यूनिट नंबर 1 में अपना अपना, ये मैं नहीं कहता कि सरदार जी हैं तो हम अपने गुरु ग्रंथ साहब की बात करेंगे, हिंदू भाई हैं तो उसको गीता की बात करेंगे, ये सब हमारा अपना है। एवरीथिंग इज अवर ओन इंडियन सिस्टम। एक एक बात जो हमारे पुरखों ने हमें कही, उनको भी हमें ध्यान देते हुए अपने बच्चों को पढ़ाना है, ठीक है ना। अब अभी देख लीजिए, जैसे रामायण हम चलती थी तो हम बोलते थे कि तीर मार रहे हैं तो ऊपर ब्लास्ट हो रहा है, और अभी वो मिसाइल सिस्टम हमारे यहाँ बन चुके हैं। वही चीज तो है कि हमने बटन दबाया और यहां से मिसाइल निकली और वहां से कोलैप्स हो रहा है, और यहां से किसी ने मिसाइल फेंकी तो हम यहां से उसको डी मिसाइल करके ऐसा बाहर निकाल रहे हैं कि रास्ते में उस मिसाइल को हमने कम कर दिया। तो ये शक्ति प्रदर्शन हुआ करता था पहले, हमारे वेदों में लिखा हुआ है, वो चीज अब साइंस में आ गई है, तो वेस्टर्न बन गई है, और हमारे इंडिया के जो जितने भी पेटेंट्स है, जितना भी हमारा आईपीआर था, वो बाहर चला गया है। तो अब हमें उन चीजों को लड़ने के लिए हमें अपने चीजों का रेफरेंस देते हुए प्रूफ करना होगा, साथ साथ में हमें ये प्रूफ भी करना होगा कि हमारा इंडियन जो इंडियन नॉलेज सिस्टम है, इसके लिए एक्सपेरिमेंट भी आप डिजाइन कीजिएगा। आप लोग तो गांव के स्टूडेंट को भी पढ़ाते हैं, इतनी ज्यादा नॉलेज उन गांव के बच्चों के पास है। हम लोग तो कभी कभी दंग ले जाते हैं बॉटनी के लिए, ऐसी ऐसी जड़ी बूटियां उनके पास हैं कि जो घाव पे लगाया और घाव 24 घंटे के अंदर एंजियोजेनेसिस हो जाता है और वो घाव भरना शुरू हो जाता है। और ये तो मिरेकल हुआ ना, ये दवाई अगर अमेरिका के पास चली जाए तो वो तो करोड़ों रुपया कमा लेगा। ये हमारे आदिवासियों के पास ऐसा ज्ञान पड़ा हुआ है। तो ये ज्ञान को, इस प्रकार के ज्ञान को, ये इंडिजिनस ज्ञान है हमारा, इसको साइंटिफिकली प्रूव करते हुए उस आदिवासी प्रजाति का भी आईपीआर में नाम लेते हुए, हमें जोड़ते हुए आईपीआर लेना है और आईपीआर के बाद हमारे सिस्टम्स में लेके आना है। बहुत बड़ा चैलेंज आ गया है नई शिक्षा नीति का, और हमें अपने बच्चों को इंटीरियर्स में भी भेजना है डिसर्टेशंस के रूप में। ऐसा नहीं कि बड़ी बड़ी कंपनियों में बाहर भेज दिया हमने, बेंगलोर भेज दिया, हैदराबाद भेज दिया, लेकिन हमारे बच्चों को एक दिन के लिए मंडला जैसी जगह में या पतालकोट जैसी जगह में भी हम अपने बच्चों को एक्सकर्शंस के लिए भेजेंगे, उनका भी इनको नंबर मिलता है। तो ये भी हमारे सिलेबस में आना चाहिए। तो ये सारी चीजें जब डॉक्टर पचंडोक का जब लेक्चर चल रहा था मैं सुन रहा था, एंड इट वाज वंडरफुली एक्सप्लेन। और आज मैं कोशिश करूंगा कि सर अपना एक लेक्चर सारे पार्टिसिपेंट्स को भी दें जो कि एनईपी से रिलेटेड हो। तो आप सबका स्वागत है, और जो भी कोई प्रॉब्लम हो तो मुझे आप कांटेक्ट कर सकते हैं। मुझे पूरी उम्मीद है कि संजीव जी बहुत अच्छा केयर करते हैं। संजीव जी इज अ वंडरफुल मैनेजर ऑफ एचआरडीसी, एंड संजीव जी ने आज तक जितने कोर्स करवाए हैं वो बहुत ही बंधे हुए, बहुत ही अच्छे। और जब आप लोग जाते हो 12 दिन के बाद, जाने का दिल नहीं करता। मैंने देखा कई पार्टिसिपेंट तो इमोशनल हो जाते हैं कि संजीव जी ने इतना अच्छा कोर्स कराया, हमें और लंबा कोर्स अटेंड करना है। तो मैं बोलता हूँ नहीं, नेक्स्ट कोर्स आप फिर अटेंड करिएगा। सो थैंक यू वेरी मच डॉक्टर चंडोक फॉर ज्वाइनिंग एज ए कोऑर्डिनेटर. Thank you very much, Dr. Sanjeev ji, for organizing more than 90 people for this course. और मैं अपने मैनेजमेंट को भी धन्यवाद देता हूँ जिन्होंने हमें गूगल का प्लेटफॉर्म दिया है, गूगल खरीदने के लिए दिया है, जिससे कि हम आज ये ऑनलाइन प्रोग्राम्स कर रहे हैं। धन्यवाद आपको सबको, नमस्कार, वेलकम।
थैंक यू सो मच सर, थैंक यू सो मच। आज के इस स्वागत समारोह के में हम लोगों ने प्रोफेसर संधू सर को सुना।
देख लेना है?
अब मैं संधू सर से निवेदन करूंगा कि आज के इस कार्यक्रम को हम लोग विधिवत प्रारंभ करने की आपसे अनुमति चाहेंगे।
बिल्कुल 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 अनुमति है, और अच्छे से चले ये प्रोग्राम, मेरी शुभकामनाएं हैं।
थैंक यू सो मच सर, थैंक यू सो मच।
थैंक यू। मुझे आशा है कि मैं अब लॉग आउट कर लूं तो कोई प्रॉब्लम तो नहीं होगी?
जी सर, कोई प्रॉब्लम नहीं।
प्लीज कंटिन्यू। मैं बीच में
आपका लेक्चर कितना होगा सर?
मैं आपको बहुत लेक्चर देने वाला हूं, इस बार छोड़ूंगा नहीं। जब भी फ्री होंगे तो मैं आ जाऊंगा उसमें। जब भी स्लॉट खाली होगा तो आई विल कम। पावर ऑफ सबकॉन्शियस माइंड। पहले आप चंडोक जी को तो सुनिए, पहले क्वांटम सुनिए, फिर मेरे पास आइएगा।
अरे नहीं, आपको पहले सुनना है सर, आपको पहले सुनना है। आप बहुत अच्छा, बहुत बढ़िया नॉलेज।
आपका भी लेक्चर रखे सर, पावर ऑफ सब और से एक बार सुनना है सर,
इस बार मैं 100% इस बार, और हो सकता है क्योंकि मुझे 23 को दिल्ली जाना है, उससे पहले ही मैं आपका एक
एक लेक्चर चंडोक सर का भी चाहिए।
हाँ जी, हाँ जी,
बिल्कुल।
ओके, थैंक यू वेरी मच। ओके, नमस्कार।
थैंक यू सर, थैंक यू वेरी मच। आज हमारे बीच आज के रिसोर्स पर्सन प्रोफेसर संजय ढोबले सर हम लोग के बीच में हैं। मैं डॉक्टर तुषार से निवेदन करूंगा कि वे सर का इंट्रोडक्शन दें एवं लेक्चर प्रारंभ करें।
Thank you, sir. Thank you very much. Am I audible to all of you?
Yes, audible.
Hello.
हाँ, आप सुन, हाँ आ रही आवाज आ
Am I
रही?
audible?
हाँ, ऑडिबल है, आप बोलिए।
Hello.
हाँ तुषार, आप बोलिए, आवाज आ रही है आपकी।
आवाज। Okay. So it is my privilege to introduce our today's chief guest, Professor Sanjay Dhoble sir. He is senior professor at Rashtrasant Tukdoji Maharaj, Nagpur University, Nagpur. Sir has done his MSc degree in physics from Rani Durgavati Vishwavidyalaya, Jabalpur. So he is the alumnus of the university. He has obtained his PhD degree in solid physics from Nagpur University, Nagpur. It's a quite huge biodata. Sir has about 31 years of experience in undergraduate and postgraduate, and 30 years of research experience. He had given around 178 plenary talks, keynote address, invited talks, guest lectures, and also visited various countries such as Italy, Egypt, Japan, Australia, Hong Kong. Some of the few I am mentioning over here. Sir has published around 907 papers in Scopus. He is having Google Scholar citation around 6,297 and H index of 53. Sir has edited and authored 30 international books. He had published 74 patents, which is again a huge achievement, and it should be mentioned. Only 40 out of which 48 are already granted, and 13 are granted patents are 42. One is South Korean, 13 are from South Africa, and 13 are from Australia. He had guided 78 PhD students. Sir has got awards such as Sir has got Top Scientist Award.
Hello.
So this is Sir's total biodata. It's very huge. I welcome Dr. Dhoble sir to our basic science refresher course. And again, I am thank you to the Pandey sir for giving me this opportunity to introduce our today's guest. Thank you very much. Over to Dr. Sanjeev Pandey sir.
वेलकम ढोबले सर, प्लीज आप अपना व्याख्यान.
गुड मॉर्निंग सर.
गुड मॉर्निंग.
आवाज आ रही है ना?
आ रही बिल्कुल.
वेरी गुड. Sir, you give me the permission for screen share. Just to screen share, sir, please. आपका आवाज नहीं आ रहा.
हाँ संजय जी, मैं दे रहा हूँ, एक मिनट.
हाँ, स्क्रीन शेयर दे दीजिए.
Good morning, Dhoble sir.
गुड मॉर्निंग सर.
Dr. Chandok.
हाँ सर, बस तुम्हारे आवाज
good morning.
दुनिया पहचानती है सर. आपको नाम बताने की क्या जरूरत
अरे सर आपको नमस्कार है सर. आपको नमस्कार.
नमस्कार सर. आपके आदेश के हिसाब से पहुंच गया सर.
अरे सर आपने निवेदन स्वीकार किया, धन्यवाद आपका सर.
अरे नहीं सर, करो
जी
सर. हाँ,
गुड मॉर्निंग सर.
गुड मॉर्निंग अतुल भाऊ.
गुड मॉर्निंग सर.
हाँ, स्क्रीन शेयर हो गई.
गुड मॉर्निंग सर. हाँ, शेयर हो गई सर. थैंक यू.
हाँ, फुल स्क्रीन आ गई.
सर आपको डबल
यस सर.
हाँ, करेक्ट.
टू एंड स्क्रीन मोड तो आ जाएगी, फिर सबको विजुअलाइज हो जाएगी.
हाँ, आ गई.
यस सर.
विजिबल ना?
Yes, sir.
Okay.
Yes, sir.
Yes, sir, it is visualized.
Thank you. So I'm very happy. My friend, my mentor, Dr. Sanjeev Pandey sir is inviting me for this talk, and my other very close friend, Dr. Chandok sir. So both are is very my heart, some part in the Jabalpur, and they are ordered me to please deliver the talk. So I'm very happy to present here. One of the student Atul is also present, other are also present. So good morning to all. So today I'm present my talk on the 1 minute. On this title is the Advancement in Phosphor Materials and their Multidisciplinary Investigation. So this talk is totally depending on what is the application of the phosphor. So it is very important. We are working on the LED material or radiation dosimetry material. So some material emit the light, it is called a phosphor. So I'm working on this phosphor. So it is very important what is the application of phosphor. So just you can see this luminescence material and their properties and application. So first I'm discussing what is the phosphor and this one. So this is a very easily explanation. The luminescence process is indicated in this screen. So just electron present the ground state, and you can excite this material by a photon. So Hν energy of the photon absorbed by this electron, and this electron reach at the higher energy state. And just this electron reach at the high energy state, then it is possible to again the excited electron not possible to stay the long time to the higher energy state, again come back to the ground state, and after this come back to the ground state, this electron emit the sum of the energy in terms of the photon, and this emission of this photon, it is called the luminescence. But sometimes this electron absorb the more energy, so this electron again jump to the again higher energy level, and then this electron in the n equal to n3 energy level, again higher energy level. But again the same thing is happen with this excited electron. It's not possible to stay the long time to the higher energy level. Just you can see this electron here. So this orange, this is called the excited transition, and electron come back to the ground level. This is called the emission transition, and during this emission, this is the emit the some electron. Then this is called the luminescence. So luminescence, it is a different type of luminescence. Is the totally depend on the excitation process. This is the chemiluminescence, this is chemical reaction. Bioluminescence, the biochemical reactions. Electroluminescence, just you can pass the electroluminescence. It is not possible to explain the everyone luminescence. I'm here explain the photoluminescence and thermoluminescence and sometimes the bioluminescence to here. So just application of the luminescence, just you can see here. So different number of application of this material: lamp, laser, display, LED, TLD, and link, ink. So many type of the applications, and this is all very very interesting application and different application in the different field. So I'm trying to work in the luminescence application with a different subject. Then I'm called this the multidisciplinary application of phosphor. So I'm trying to work with the different different department. Just I'm working in this different application. Just the LED application for the artificial lighting, solar cell efficiency enhancement, tail radiation dosimetry, ion beam irradiation, plant cultivation, fingerprint, long-lasting and road traffic safety, biosensor, antimicrobial activity, phototherapy, mosquitoes repellent, and machine learning on phosphor. Also, I'm working as some geological material for radiation dosimetry, fabrication of biomedical devices, fabrication of device for the Ayurveda, and some other subject. I will also working on this one. So this is the one of the subject is working in the different subject. Then we are called this is the multidisciplinary application of phosphor. So I'm discuss one by one some of the application. Or all application is not possible. So phosphor for LED application, it is in the artificial lighting. So just you can see the all type of the sources are here, and just everyone's sources is create the artificial lighting. So but all these sources, it is some of the drawbacks. So I'm just converted into some generation. So this is the fourth generation. So one generation, second, third, and fourth. So some of the problem in the one generation, this is the removed by the advanced technology. Then second generation, and we will try to the this artificial lighting for the two point we are consider. One is the eco-friendly of nature of the devices, and second is useful for the society. So on this basis of I'm just working on this fourth type of the generation. Just as the first generation lighting is the kerosene based lighting, but it is emit a very dark fumes, and it is contain the carbon oxide or carbon monoxide, and it is very harmful to the health, and it is not possible to, you can call this the eco-friendly lighting. So next generation lighting, it is a tungsten filament lamp. So it is the lifetime is the 1000 hours, but just you can see that this lamp is consumed the 4 times more electricity as compared to the CFL lamp. And just you can touch this lamp, then it is the heat generated. So in the room, this is the some of the oxygen is converted in the carbon dioxide, and within the 1000 hours of the lifetime of the lamp, it is emit the half ton of the carbon dioxide. So it is very it is not considered the eco-friendly. So and it is a very costly in terms of the electric power. Is consumed the 4 times electric power as compared to the CFL. So this is again, it is not the eco-friendly. Then again, somewhat is going on this. And next generation lighting is the fluorescence lamp. Just fluorescence lamp, just you can see this is the, but it has the internal part is like this. And
नहीं आ रही ढोबले सर?
I think sir का internet connection unstable है.
इंटरनेट का थोड़ा सा ये हो गया।
हेलो।
आज नहीं आ रही है अभी।
पांडे सर, सर का लैपटॉप हैंग हो गया, रिस्टार्ट कर रहे थे हम।
अच्छा
सर का आया था।
ठीक है, ठीक ठीक ठीक। लैपटॉप हैंग हो गया। तब तक आप लोगों को थोड़ा सा मैं देख तो लूं कौन आए हैं, कैसे दिखते हैं। वीडियो ऑन करेंगे तब दिखेंगे। हाँ, नहीं तो मैं लोग वीडियो ऑन कीजिए ताकि मैं एक
लैपटॉप हैंग हो गया सर।
और लोगों का वीडियो ऑन हो जाए। नहीं तो मैं चेहरा ही नहीं पहचान पाऊंगा, कल को मिलेंगे तो फिर कहाँ से हम लोग बात कर पाएंगे। संजय सर, संजय मिश्रा सर,
जी सर।
आपका नाम मैं लिख देता हूँ, ठीक है।
हाँ जी जी।
कहाँ गया, रीनेम कर दूं। रीनेम, बस इतनी।
थैंक यू सर।
हम्म।
अरे गुप्ता सर है, गुप्ता
हाँ,
सर।
अभी देखिए,
ओम
अब आप
प्रकाश।
लोग एक दूसरे को पहचानेंगे, नहीं तो समझ में ही नहीं आएगा कौन थे। अब सब कोई दिख रहे हैं
हाँ
नहीं।
हाँ, नहीं नहीं दिख रहे, पिछले टाइम पे
हाँ।
थे ना, आर्मी में थे, ओम प्रकाश गुप्ता सर।
प्रीति कुछ बोल रही हैं।
हाँ, और
आवाज नहीं आ रही, माइक नहीं चल रहा लगता है। प्रीति, आपकी आवाज नहीं आ रही है ना, नहीं आ रही है। संजय ढोबले सर ज्वाइन कर लिए। पीएस भी ज्वाइन कर रहे हैं। पूरे दिन के कोर्स में एक बार हम लोग अपना वीडियो ऑन करके एक दूसरे से मुलाकात करके गुड मॉर्निंग बोल लिया करेंगे, ठीक है। आ गए, ढोबले सर आ गए। हाँ ढोबले सर, करिए स्क्रीन।
हाँ हाँ, मैं जस्ट ये कर रहा हूँ, शेयर स्क्रीन कर रहा हूँ।
हाँ,
एक मिनट। ऑफलाइन क्या करो सर?
हाँ मैं ऑफलाइन करने। अगर अब हम लोग के प्रतिभागी बोलते हैं कि सर ऑनलाइन में काम चल जाता है, काय को ऑफलाइन बुला रहे
सर ये सब प्रॉब्लम जनरेट हो जाते हैं।
हैं।
एक मिनट सर, एक मिनट, आई विल ट्राई। हाँ सर, आ गया।
आ गया।
ओके। ओके सर, सॉरी। सो फॉस्फर फॉर एलईडी एप्लीकेशन। सर आवाज आ रही?
बिल्कुल बिल्कुल आवाज आ रही है।
Okay, artificial lighting. So all this is converted in the fourth generation. So I'm just explaining the one by one here. So this is the kerosene-based lighting. It is a very harmful and continuously emit the carbon dioxide, carbon monoxide. So this is not the eco-friendly, that we are not consider this is the issue for the society. So next generation lighting, it is a tungsten filament lamp. It is the lifetime is the 1000 hours, and this is the very hot. Just you can switch on, that temperature of this cover is very hot, and it is consumed the 4 times electricity as compared to the CFL lamp. So within the 1000 hours, this lamp emits a half ton of the carbon dioxide. Then this lamp again we are cannot consider as the eco-friendly. So next lamp, it is the fluorescence lamp. So internal structure of this fluorescence lamp, just you can see, this is the red part. It is considered the mercury, and it is the content of the mercury. It is the 44 milligram. So just you can apply the electric field, then mercury is converted in the gaseous form, and this is the excited the internal phosphor. It is the red, green, and blue phosphor, and white light is emitting. But this lamp, it is the out of order, so it is not a proper disposal. So this 44 milligram mercury is spread in the open atmosphere, and this is very harmful for the soil, water, and health also. Again, this lamp it is not eco-friendly. So next generation lamp, it is the CFL lamp, compact fluorescence lamp. So just you can see, this is the compact fluorescence lamp available, different shape and size in the market. So it is very decorative, but again, this CFL lamp also operated on the mercury, just indicated the figure. So it is a quantity in the 4 milligram. 4 milligram, it is also, it is not the properly disposal. Then 4 milligram of the mercury again creates some environmental problem, that we are not consider this is the very good eco-friendly lamp. So again, some modification in this lamp. And just you can see this type of the picture everywhere in the place, in the government and private places. So each fluorescence tube, it is a 44 milligram, CFL lamp is 4 milligram. So all this lamp mercury open spread the open atmosphere. Due to that, it is not the disposal problem properly. So again, it is work is going on. So what is the ultimate solution of the artificial lighting? So only one solution, it is the LED lighting, light emitting diodes. So this light emitting diode, it is replace the CFL, and just you can see, this is the advantage of this LED. It is a lifetime of the 1 lakh hours. It is a no moving part. It is a very small size of this one, and available in the different colors. So this is the lamp. It is also the energy efficiency, the 90% power saving. So it is also power saving lamp, and in this LED lamp there is no mercury. It is not no mercury, then this is not the create any type of the environmental problem. So LED lamp, it is the eco-friendly as well as to the power saving. So this is the ultimate solution of the lamp. So for this purpose, we are developing the 3 type of the color: blue, green, and red. All 3 color combined, it is the emit the white color. But so blue, 2 color LED also available in the market. You can excite it by the blue color. So yellow emission you can observe. So blue and yellow, it is also with the white color. And near UV light, you can excite it. The green, blue, and red is also combined the white LED. So this is the source of the white light emitting diode. So this tricolor LED, it is the emission. Just you can see the blue, green, and red, and that combined emit the white color according to this color. So this is the different type of this LED available in the market for the different application. So just in our laboratory, what is our target? We are trying to develop the phosphor in the blue, green, and red. So this is the first, just you can see all these 3 phosphor under the normal light, but you can excite it by the near UV. So this is the red, blue, green phosphor observed to here. So it is very useful to development of this the phosphor by low cost and non-toxic process. So our lab is totally working on the development of this 3 color phosphor. So for this purpose, we are using the rare earth, and this is the all rare earth is not possible to work. So only for the U, C, DY, TB, SM, all this some of the rare earth we are using. This show the different light emission, and this is the different type of the host material: aluminate, borate, fluoride, nitride, oxide, phosphate, sulfate, sulfide, titanate, tungstate, vanadate, and silicate. So all these phosphor host material are used, and this rare earth dope in this phosphor, then you are possible red, blue, and green phosphor. So thus some of the methods for preparation of this material: solid state method, wet chemical method, and the combustion and solvent method. So just you can see this is one of the phosphor, the U2 plus, Sr3Al8, SiO70, U2 plus. So excitation is the 354 nanometer. It is far away from the mercury excitation, 254 nanometer. So this 354 you are considered the near UV excitation. After you can excite it, so emission the 486 nanometer in the blue color of the spectrum. So this is the one of the blue phosphor for the white color. So next, it is the phosphor is the Sr3Al8 SiO70 U3 plus phosphor prepared by the Solgel method. So this is the, you get excited by 394 nanometer near the UV excitation, emission around to the 612 nanometer due to the 5D0 to 7F transition in the red color of the spectrum. So this phosphor, just you can observe the red color. This is the second phosphor for the red color, one of the component of the white color phosphor. Now next one, it is the, just you can see next phosphor. It is the green color. It is the Sr3Al2O5Cl2 yellow phosphor. It is the TB dope, and it is the green color. So for the excitation process, the which type of the material are used? So in the China and Taiwan, it has a strip of this indium gallium nitride with the different concentration of the indium just observed, and according to this concentration, different excitation near UV is emitted. This is useful for the excitation sources. So one of the phosphor, just you can see, this is the dope with the European, the red phosphor. In the 650 nanometer, in the PR, the emission is the 598 nanometer, and this U2 plus is the blue emission, the 485 nanometer, and you can excite it, then this is the combined white light emission. So you can develop the high intense and low toxic and good material or low economical phosphor. So this is the good technique for the work on this number of combination of the excitation emission wavelength. Chemical route synthesis, you can vary the different route of synthesis. Starting material, you can also change some nitrate, carbonate, oxide also. And heat treatment, you can change the different temperature. So in all these cases, some of the intensity of the luminescence is the increasing. Other way, you can change the host material. It is also possible. Just you can see, this is the VO4, BO3, MO4, WO4, PO4. It is also replaced in this material. Then it is also the host changes. Then it is possible for, and it is called the peak shift with the changes. This is called the color tuning. So controlling the doping level of the activator ion, varying the concentration of the sensitizer and activator. It is also changes, combining the emission of host material like the tungstate, molybdenum, vanadate within the emission activator. And next is the cation variation also possible, anion substitution also possible. But sometimes you can select the cation as well as to the anion substitution also. So all this process, it is possible intensity of the luminescence is the increasing, and this is the intensity is increasing. So this is a very good figure. Just one of the component, the Ba2 Mg PO4 whole twice. This is the initial compound. It is the blue emission phosphor where X equal to 0. But this PO4 you can replace by the BO3, and this is the X value of 0.2. So second peak is observed. But at a particular position, X equal to 1, both peaks are observed, and X equal to 2, then only again second peak is observed. So this is blue color, then again shifted to the red side. So this is called the color tuning, and this figure, it is called the graphical extract of this our result, and very interesting for the publication of the very good paper at the high impact factor. So now next compound, just you can see here, CaGdLO whole thrice BO3 whole 4 U3 plus is the red phosphor, and just you can see this red phosphor just in the 397 excitation emission in the completely red spectrum in the 621 nanometer, and this is the one phosphor per red, two phosphor are selecting already available. BAMU, it is a standard blue phosphor, and BASR2 SiO4 U2 plus is the standard green phosphor. So combination of this phosphor with the blue and green, this we have observed. So this is the white phosphor, and this white phosphor useful for the red white color LED. So this is the white color LED required this three type of the phosphor. So some of the paper is published on this one. Is the impact factor the 6.317. Again, just you can see. So some of the other paper is the 7.6 in the material today chemistry, and now again some of the phosphor is the 7.7. It is the by Kadam and Govind Nair. This is the very general environmental chemical engineering. This is a high impact factor. So this is the important for this. So next is the progress in solid state chemistry. This is 8.389. This is one of the review paper is also published on the solid state lighting. This is a very good, interesting material. Now this is the one of my students, the Paude, published one of the review article for the blue emission by the combustion method. It is the 16.799. So this is the high impact factor also possible on this work, and this is the interesting work. Second is again the Tejo Kalani published some work in the organic light emitting for the 16.799. Again, this is another paper 16.799. So continuously you can increase the high impact factor with a good quality paper, and then student is placed in some of the good institute, just like the Paude and Kalani, both in the Lakshmana Institute of University in the Nagpur, and Govind Nair get the PDF. Karthik Sindhi also get the PDF. So 14 students also receive the postdoctoral fellowship on the basis of this high impact factor paper. So this Karthik Sindhi is published one of the good material by the this is the red chemical method. It is the impact factor 31.655. So this is with one of my international collaborators, the K Park from the South Korea, and this is our second student is the Govind Nair working with the SC SWAT in the South Africa. It is the 48.165. This is the paper in the progress in material science. Again, one of the students, the MD Mere and Chaitali Mere, also published one of the review paper in the progress in material science. The same impact factor 48.165 with my very dear collaborator is Professor S. Swart. So this is the international collaboration, and the students are motivated and continue day and night working on this topic. So high impact factor is possible, then you can get easily the job. And sometimes some of the material is the patentized, and this is the Indian patent, Australian patent also, some of these, so though patent also possible. Now second application, the phosphor for enhancement of the solar cell efficiency. So just you can see this is the solar spectrum indicated in the green, and red it is some emission. So our material emission in the under this is the spectrum of the solar. So this is in the part, so this is an excess photon also considered for this one. Then the efficiency of the solar cell is increasing. So for this purpose, we are just select the photovoltaic silicon cell. It is the efficiency the 15 to 20%. So this material, this is directly purchased, and by Dr. Plate method, material is coated on this one, and then just you can see this according to figure. This is silicon, it is the juice, and then our material coated in the B figure by Dr. Blade method, and the material, and just by this the solar cell simulator, we can measure this is the current versus voltage graph, and this graph is showed that the material show the efficiency increasing. So this is one of the material KLX4. It is just dy and U dope, and this is the emission in the observed. So it is the efficiency increased by the 30.542% in the solar simulator efficiency light, and the direct sunlight, it is the efficiency increased by the 37.73%. So this is the very good result observed by the solar cell efficiency. And now this paper is published in the 6.317. So this is general aligned compound by Abhijit Kazam. And now this is another paper in the Jagdish Parwa. It is also published a very good paper in the 3.925 by the LAPO4 with the dy and U activated. So everyone student try to working with the high impact factor paper Na21CA4 Na4PO418. This is also material dy UTB triple dope material also useful for the efficiency of the enhancement. In this case, the 43.33% efficiency enhancement. So this is the very 20 plus 4, then 24 in the silicon cell efficiency increases. So this is a very good result of our material. And this paper is published in the 37.6 by Abhijit Kadam. And this is another paper, another patent also on this, the Australian patent. Just you can see this is the Australian patent. So now is the phosphor for the display device. So LED phosphor is also useful for the display device. Just this is the three type of the material, red, blue, green, and this is the combinedly emit the one physical form. So this is the useful for the display device. Just you can see this is the module, and then this is a very useful. It is a synchronize all the screen in the particular intensity, and this is a display you can observe. So just now next application, the phosphor for the long lasting and road traffic safety. So some of the material just you can U dope, then show the emission intensity, the blue color, but it is the decay time is very less. So we are dope in this material, the European. So decay time is the 120 second, but we are dope in the dy in this material. So decay time it is the 8 minutes. So this material useful for the road safety, and then this is very useful. So some of the traffic signal and other applications, so this is also very useful. Now major application of this phosphor for the radiation dosimetry, and it is a very, some of the people of Indian BRC, Raipur University and Jabalpur University and our group also working in this one. So thermoluminescence TLD dosimetry. The thermoluminescence technique, just you can see this is the number of the characteristic, high sensitivity, emission falling in the range of the common available detector, no fading, and the simple glow curve, it is the repeated after the hitting also. So all these 11 type of the characteristic, but in the material is the 7 and 8 characteristic. So it may be useful for the dosimetry purpose. So for this purpose, we have just explained the one material K3NS4 twice U. So this material prepared by the two method. What is the evaporation method? And second, it is the directly melt method. So this is the evaporation method is prepared. So this evaporation method XRD is well matched with the standard dissipate file. But K3NS voltage you can melt. So it is the two-phase compound is the KNS4 and K3NS4. But this melt method compound is a very high sensitive to the well-known standard cell-support device developed by the Bhabha Atomic Research Center, and it is a 6 times higher as compared to the our cell-support device phosphor, and it is the emission in the blue color. So this glow curve structure you can dope with the europium in the different poses of potassium or sodium or K3Na. So glow curve structure is not changes on the intensity or variation, but you can compare this compound in the different exposure. Their glow curve structure not changes. This is the main characteristic of this material, and it is intensity is the 6 times higher. Just you can see it is the response curve with the comparison with say support device. So our material is the best as compared to the standard say support device. So this is the quality of the our research, and this is the blue emission. It is very useful for the this is the directly useful for the well sensitized the photomultiplier tube in the TLD device. So this is the very useful, and this is decay also very less. That is a completely useful for this one, and this is the useful for this type of the TLD batches. And this is the figure just you can. Then this is the total applied work, and then it is possible with the good paper publication on this one. Just you can see this is the 4.1177 paper. This is the 4.171 again. Again this paper, and just you can see this is the 3.409. It is the SR5. PO4 whole thrice Clu2 plus phosphor, and this is the very important for the preparation of this material. So now just this is the paper also published in the RSC, the 4.036, and this is the next the BRC developed the CO2 device. So in some of the code doping, this material also sensitized, and it is the CO2P device. So now this impact factor 3.66, all this magnesium boron, and some of the this is the dinosaur bones. It is also this is the fossil, and it is the high sensitivity. It is the threshold is the very maximum. So
तुमसे काय म्हणे होती कुठली
सर आवाज कुठला आहे आवाज कहाँ से है So again this is the turtle shell. It is the fossil. It is also the useful for the hydrodosimetry. Then it is the threshold of the radiation is very high. So geological material also useful for this purpose also. Now next application, recently our group also working on the up-conversion phosphor for cancer therapy. So this is the up-conversion material prepared in our laboratory, and the other collaboration in the pharmacy. So here it is the some of the phosphor. Just you can see this is the near NR lamp. This is collide to the cancer cell. This is the kill the protein of this cancer cell, and then this cancer cell is the kill. So for this purpose, it is useful for the some of the YB type of the activator, and this material also prepared our lab for the image. This is the NR emission. So then this the up-conversion material also possible to develop in the laboratory, and some of the students are working in this field also. So these are the all phosphor possible you can prepare in this one. Corrected exposure during the radiation treatment of the cancer patient. So this is a very important. So during the treatment of the cancer, you can expose the body. So some is the body is up and down, so the 2 or 3 inch. So then it is not possible to the exact dose for the particular place. So it is the sum of the error. This error calculated according to the this is the physician at that place. You can change the this is the variation of this one, and correct exposure is is possible to the patient. So this is the major treatment of the delivery dose by the patient. It is also work on this very important, and some of the paper also published on this by my students. So these are the very interesting to this, and just you can see here. And this nanoparticle dope for the bone cement, just the our material, luminescence material mixed with the bone cement, and just you can use this is the radiopathy or some of the place in the treatment, and this is the bones. So then you can excited by the UV lamp, so you can find out what is the position of this fracture and all this thing. It is possible you can treat. Just you can see here, this is the bone cement. We can dope with the mix with our phosphor, and you can expose by the UV light. Then it is possible this type of the things. So this is very useful for this the one. That luminescence bone cement is very important for the safety and consideration, and it is a different type of the application. So this is the depth of the detection. It is also possible with help of the bone cement with the UV material. So now the carbon ion beam. So carbon ion beam, it is a very important. Now this is facilitating the Inter-University Accelerator Center, New Delhi. So some of the collaboration is going on in the Inter-University Accelerator Center. So carbon ion beam, it is a very heavy mass, and it is the one black peak. So this ion just directly collide to the cancer cell, and then after that it is not possible to again enter the cross this cancer cell. The maximum energy released in the cancer cell, and then this is the cancer cell, it is a totally damaged, and then it is the very useful for the treatment in place of the gamma ray. So gamma ray is the all penetrated, so other part of normal tissue also converted in the some damage, and it's possible long time exposure, it is converted in the cancer. So carbon ion beam is very useful due to this carbon ion beam. So our material also you can expose the IUIC with the carbon ion beam. Just you can see this is the experimental procedure, and thus impact of the carbon 5+ ion beam on the DY activated SR2B509Cl phosphor, and very good result you can observe for the dosimetry purpose. So this is another paper is the carbon 6+ ion also. This is the depend on the energy. And this is one of the paper is published in the scientific report. This is the Nature publication with one of my UK collaborator Alexander Crispy with the Karan Kumar Gupta. He is working presently in the Taiwan, and this is the impact factor is the 4, but this paper is a Nature publication. So all type of the publication is possible. Now phosphor for the antimicrobial activity. So just copper particle you can prepare by the agal plant. This is the Belpatri plant, and this is a very simple procedure. For you can take the extract of this plant. After that, you can mix the copper nitrate, and you can take the evaporated and centrifuge of this particle. So exactly just you can see this nanoparticle, and this is a particle size is 16 nanometer. It is near to the this is the very small particle, 1 to 10 nanometer. So this is very quantum dot. So this is the very good particle, and then its potential energy is potential application is much more. And it is the emission observed in the blue color of the spectrum of the carbon, copper ion. And this is the antimicrobial study. You can show that this is good to show the antimicrobial activity of this material, and then this is useful for some of the cosmetic or biomedical application. So green. So green synthesis assist the copper nano. Similarly, just you can see the another material is the emission, the red color, the 616 nanometer in the red color of the spectrum, and just the particle size is the 73 nanometer. It is also show the good antimicrobial activity, but pure and the rare earth ion. And so this microbiology people is not working on the pure material, but we are using on this rare earth ion. Well, what is the effect of the antimicrobial activity? So it show the good antimicrobial activity. So of this our phosphor material, and this result also published in a very good level. Now phosphor for the plant cultivation. So this is the again the 430 to 50 to 520 nanometer is useful for the photosynthesis. 595 to 620 nanometer is for the phototropism, and far red means above the 630 nanometer. It is the photomorphotropism. This is useful for the growth of the plant as well as increase the fertilization of this one. So this is the some of the material is the MM-TTC plus, and emission in the very far red result. So it is useful for the develop this type of the greenhouse with the LED base, and this is the very small space of the vegetable and number of floor, and that maximum output is possible from this place. So this is the one of the NASA astronaut in the space in the 229 days, 8 hours, 41 minutes. And this is the this type of the food for the LED one. So this work is done with one of the Samudrapur College, Vidya Prakash, and then the botany head is the Naina Ashirwad. This is our artificial greenhouse, just you can see here, and good result all also like this one. And some of the paper on this just you can see here one. And this is some of the South African pattern also published. Now is the very interesting one is the cow. Phosphor LED light you can useful for the increase the cow milk. So this cow you can expose by LED light by the 16 hours. So this is the 8% cow milk is the increasing. So I'm just trying to find out the particular which wavelength is responsible for this, and this work is continuously going on how to increase the again milk more than to the 8%. So this work on the basis of phosphor is going on, and I'm trying for this one phosphor for the phototherapy. So this type of the psoriasis is the different type of the psoriasis, and just 314 nanometer light you can expose on this skin. So this is the very possible to that good treatment. So the UVB light is the 311 to 350 narrow band emission, and this is possible by the GD3 plus ion, and you can enhance the intensity than C, BI, PB, or PR. It is the intensity is the enhancement. So some of the material developed in my lab and published a very good paper on this also. So this is the localized exposure that we place at the particular, and this one you can expose by the very short good device. So it is not possible to the all body you can expose. Newborn baby also infected by the hyperbilirubinemia, and this is also possible by this lab. So this is a very interesting work on this phosphor by treatment of the psoriasis, and some of the good paper is published on this data also. So just you can see. Next is the phosphor for mosquitoes repellent. If the mosquitoes is not possible to attract by the blue yellow color, so yellow color is the 576 nanometer. So this material also prepared in our laboratory, and this light it is the repel the mosquitoes. So this is also one of the application of this phosphor for this purpose. So now this is a good paper published in the 5.6 impact factor. Now luminescence for the biosensor. So luminescence of biosensor, just you can see this is the near to the sea. This type of the picture you observe some bacteria just emit the blue color, and this blue color, this is the picture from the Goa sea, and some of the bacteria is isolated and registered by our name with this work with the collaboration with the biotechnology with the Dr. Aarti Shanware. And this is isolated and just find out that it is affected by the gamma ray, alpha ray, beta ray also. So this is the very this paper is published, and then this student is get the good job after that. So ultimately researcher develop the biosensor also. Phosphor for the fingerprint. So this is also some of the particle. It is a very small size and it is exposed by this one. So it is also useful for this one, and this is the paper is published from the 417471. It is the sorry. So this is the one of the paper. It is the prediction of the excitation wavelength by using the machine learning. So computer based also work. We are work with the computer laboratory, and one of the scientists, software scientists, Vijay L. Bari, with this work, published this paper around emission 4.171. So this is the one, and some of the theoretical, practical facility is not possible. So it is possible ritual refinement and structure, electron vibration, UV parameter, Joule theory, Dexter method, energy transfer, color tuning, phosphor trapping parameter, and this is the good paper published on the theoretical way also. So it is also possible that different type of the work is possible and theoretical. So therefore, I'm working on the LED in the artificial lighting, enhancement of the solar cell efficiency, TL radiation dosimetry, and beam radiation, plant cultivation, fingerprint, long-lasting and root safety, biosensor, antimicrobial activity, phototherapy, mosquitoes repellent, machine learning of phosphor, and geological materials and fabrication of the biomedical device. So presently on my paper, total paper on Scopus is 947. My H index is 48, and citation on the Scopus is 13,182. On the Google Scholar, my H index is 53. Citation the 15,910. I think this is the more than 16,000 also. So today is not updated this, and I10 is the 444. So this is the number of papers published: 42, 10 to 20 is the 12, 5 to 10 is the 33, 4 to 5 52, 3 to 5 138, 2 to 3 is the 253, and 122 is the 111, and 0.445 to 1 is the 23 papers. So this is the some of the directly data from this, but it is very old data. Presently, I'm not possible to click this one. That this is the 13,000, and but in the Corona period, my work is continuously going on, and then 22, 21 is the paper is more than 280, and in the 2023, it is the 100 paper published on the Scopus. This is one of the record to publish the 100 paper on the Scopus 2023, and this is the news in the 87 Scopus for 100 paper published, like this one. So this is the possible with the good interaction with our student and with the collaborator. Then all this possible. This is the Google Scholar. Now, recently, the one of the database are available in the research.com in the material science. So, first position in the Professor C.N. Rao, it is the maximum paper published in India. It is the Bharat Ratna. Second is the Dr. Sabu Thomas, the ex-Vice Chancellor, the Mahatma Gandhi University in the Kottayam. And third position myself in the in India. So, both are the in South India. So my one of the person in the Maharashtra. So top position in the Maharashtra I'm considered like this one. So best material scientist award possible received in the 21/11/23, and then this is the again just you can see like this one. So this is the Dr. Sabu Thomas with me. And this is my topic of the main core topic is the LED phosphor, TLD phosphor for different application. So just this is the LED phosphor. This is the maximum publication on the Scopus. Now this is the again just you can see the LED phosphor and LED phosphor both place, and TLD phosphor on the top position in the Scopus. And just you can see the worldwide in the position in the one. Just you can see the fifth position in this case. So total my patent the 74, not 71, is granted is the 42, and this is the old data, and one this is. So I'm the honorary scientist, scientific and technology advisor in the Techno House and Nucleonic System Private Limited. I'm also adjunct one of the advisor. I'm adjunct faculty in the Mahatma Gandhi Ayurvedic College in Wardha and School of the Allied Health Science, Datta Institute of the Medical College, Wardha. So due to some of the work in the medical basis, so I'm visited in the Italy, Egypt, Japan, Australia, Hong Kong, South Africa, UK, Greece, China, Sweden, South Africa, Malaysia, and for the scientific purpose. This is my international collaborator and national collaborator. This is my all international collaborator. Is continuously I'm working with this person, and they are very happy. I'm also very happy with the good collaboration of this one. So I received the more than 2 crore fund by the DSC, BRS, IUSC, UGC, SCRB, Indo-Asian project also. So I'm top 2% scientist in the 2021, 22, 23 by the Stanford University list declared by the Stanford, and this is the some of the news in the display published in the Nagpur. I'm also 0.05% scientist in the world in the Scholar GPS. And here it is a 0.2% to 0.05% scientists. It is a very good progress in this one. And this is the one of the news. Just you can see Dr. Sanjay Dhoble in the Scholar GPS list. And just you can see this is also the 0.05% list. So this is the some of the news also. India Top Faculty Research Award also received in the 2018 in the Trimurti Bhavan. I'm also Best Research Award received in the by IIT University in the 2016. And just I'm visiting fellow in the South Africa, and PhD awarded student in the 78, not 70, plus 28. I'm also fellow of the Luminescence Society of India, fellow of the Maharashtra Academy of Science, and visiting field professor in the Sejong University, South Korea. The total books is the 30. Out of this, the author book 14, edited books 116, and chapter published 177, no, 115. Sorry. And these are the books, just you can see in the Elsewhere books. All these books are the Elsewhere, the symbol, just you can see. This is the cover page of this research work of the Society Interdisciplinary work is very important. I'm working the chemistry, electronics, computer science, zoology, geology, botany, microbiology, cosmetic technology, chemical engineering, mechanical engineering, pharmacy, management, economics, Ayurvedic, sociology, political science, history, and Ayurveda also. So this is all things possible. In the last time, just was the patent place in Nagpur. So maximum patent published by the Vidarbha. So I felicitated by the deputy CM by Devendra Fadnavis in the Suresh Bhatt Sabhagram. So Dr. Sanjay Dhoble is the Bhavan patent record, and this is the maximum patent from the Vidarbha. So this type of the honor is possible by this is the Teen Murthy Bhan received the Best Faculty Award. I'm just Maharashtra Academy of Sciences Fellow. This is the Luminescence Fellow certificate. And just you can see, this is my Vice Chancellor in this my room. Is the very important. This has motivated me for the research. I'm very happy by the work. So my lab is open for collaborator, but collaborator is very hardworking and sincerely. So research laboratory is temple for me, and my research is puja. So big thanks to all my student and collaborator, and I'm also thankful to the Dr. Pandey sir and Dr. Chandok sir for inviting me. So this is my email ID for Gmail and Reddit mail, and this is my mobile number as well as to the WhatsApp number. So anybody interested to contact me on this mobile or this is the email ID. So thank you, Pandey sir. Thank you very much. Thank you, sir.
Thank you, Dhoble sir. Thank you so much. Any question from participants? Anyone? The 5 minutes for the discussion. आपका माइक बंद है ढोबले सर, माइक अनम्यूट कर लीजिए। ढोबले सर आपका माइक अनम्यूट कर दीजिए। आपकी आवाज नहीं आ रही है ढोबले सर। अच्छा एक मिनट जस्ट अ मिनट सॉरी फॉर एवरीवन। एक मिनट बस अनम्यूट। हाँ चलिए अब बोल सकते हैं सबको। मैंने वो
हो गया अनम्यूट हो गया।
सॉरी माय डियर।
Okay. So any question you can contact some of the participants. Contact to me, my mail ID and WhatsApp number and mobile number also. Any question for me?
Hello. Good afternoon, sir.
बोलिए वीना मैडम।
Good afternoon, sir. This is Dr. Veena Thakur. I am from Chhattisgarh.
Yeah.
First of all, your lecture was very informative. I belong to botany field, लेकिन आपका जो presentation था, it was very nice. और how we can collaborate physics and botany, I got many ideas from your work, and I have seen your publication, so it was really very nice. एक question जो है sir मेरा, that you have done your work on plant growth, that plant cultivation. So it is we can apply the light for the cultivation of the plant. That means in the lighthouse only, or in some other way we can use this phosphorus for the plant growth.
Just is the particular type of the red, blue, green light is required for the plant growth, or some fertilization also increase. So just I observed combinedly all three color lab continuously expose the plant, then this is the maximum good result are observed. But individually you can use the blue, green or red, then it is a very less result are observed. So all three color are required for this the growth of this one. But red color, in the far red color is very important for the increase the plant as well as to the fertilization. So this is a very good result in the with the collaboration with the botany.
Okay, sir. Thank you so much, sir. Thank you, sir.
If you have any type of the problem, you can contact me. I am always work with some of the Chhattisgarh, Raipur, Bilaspur. This is my home place. No problem.
Yes, sir. Yes, sir. Sure, sir.
Sure. Any other questions?
सर नमस्कार सर, मैं आलोक जोशी।
हाँ सर नमस्कार।
सर मिल्क प्रोडक्शन में कैसे हेल्प करता है सर ये?
क्या
मिल्क प्रोडक्शन में
हाँ
कैसे हेल्प करेगा ये?
हाँ तो सर उसमें कुछ बायोलॉजिकल प्रोसेस होती है जिसमें कि जो लाइट एनर्जी आती है उससे उसके मिल्क का 8% बढ़ता है. बट आई एम जस्ट वर्किंग ऑन दिस टॉपिक and I'm identify which wavelength or which energy required for the increase the milk production. So presently it is the reported only for the 8% milk is the increasing by the 16 hours. You can expose the cow by LED lighting. But my work is going on to how many times I require, which wavelength is the maximum responsible for the increase the milk production about the 8%. So this work is the going on, sir. You are agriculture science?
Okay. No, sir, geology. Zoology.
July,
Sir.
okay, that's it. So you are always welcome in this my project. No problem, sir.
Thank you, sir. Thank you.
Welcome, sir.
ढोबले सर, अभी एक अखबार में छपा था।
हाँ।
ये जो एलईडी लाइट स्ट्रीट लाइट्स है,
हाँ,
इससे ये डिप्रेशन का कॉज बनता है,
डिप्रेशन का।
हाँ, मेंटल हेल्थ को प्रभावित करता है।
हाँ सर, उसमें जो एक ब्लू कलर कंटिन्यूअसली अगर आपके माइंड सेटअप पे आए, so it is possible, but visible light, it is not directly affect the our mind setup, but you can continuously expose the particular one type of the wavelength, then it is possible, sir. वैसे तो ये एलईडी लैम्प तो बहुत कूल लाइट है and it is very helpful, but it is a white color, but you can just expose by the monochromatic lamp or just or one type of the color, then it is possible something wrong thing.
हेलो।
हाँ सर, गोयल साहब बोलिए।
जी सर। सर आपका सेशन वेरी इंफॉर्मेटिव था, बट मेरा एक क्वेश्चन ये है सर कि आपके जो वर्क में परसेंटेज ऑफ हाइड्रोजन का कोई ऐसा स्पेसिफिक नोटिसेबल है क्या?
परसेंटेज ऑफ हाइड्रोजन?
हाइड्रोजन, यस, पीएच वैल्यू।
फॉर विच पर्पस?
फॉर मटेरियल साइंस इन डेवलपमेंट फॉर सैंपल प्रिपरेशन।
नहीं, उसमें हमने अभी नहीं काम किया सब कुछ, ऐसा कोई वर्क नहीं किया मैंने।
जी। ओके सर, थैंक यू।
अतुल भाव, अतुल जी एयरपुड़े।
सर yes sir, I am here sir.
Yeah.
Talk was very good and informative sir. Number of people were seen in our college, your talk from my laptop.
Oh.
And okay,
your students.
People from chemistry, zoology, biology, botany people.
Acha, this is the display on the screen.
Your talk, sir.
Yeah,
yes sir. Sir, this
इसमें मजा नहीं आता अतुल जी, वहाँ पे बुलाना पड़ता है उसके लिए।
yes sir.
पांडे सर, ये मेरा रिसर्च स्टूडेंट है।
अरे मेरे अतुल जी से मेरी मुलाकात है शायद, पता नहीं।
सर मैं 2 बार आया आपके रिफ्रेशर ओरिएंटेशन किया जबलपुर से।
तो वही बिल्कुल। और संजय आप ऑफलाइन आए थे?
हाँ
ये सर 2 बार
ऑफलाइन में मजा आता है पांडे जी। सर क्या आपसे मुलाकात नहीं होती ना?
सर नमस्कार सर।
नमस्कार
सर, Mongole is here.
हाँ बोलिए सर।
Sir, it is good to know that the physics people are working for the growth of plants. Being a botanist, I am appreciating this type of work, sir. Thank you so much for entering in the botany field for growing the different crops and other. It will help definitely. Thank you so much.
I am always required the botany person for my collaboration. Recently, I am working on the azolla.
Yes, sir.
So this azolla is useful for the control the mosquitoes population. So many topics are in the micro botany, zoology are interesting, and I'm working in the multidisciplinary work. So all topics are interesting. So I'm very happy if you work with me. I'm waiting for you, sir. I know that you are working in the good field.
Thank you so much, sir, for information.
Okay, sir. Thank you very much, sir.
सर नमस्कार, मैं डॉक्टर ओपी यादव, दिल्ली यूनिवर्सिटी।
हाँ बोलिए ओम प्रकाश साहब।
सर मैं भी फास्फोरस क्लोरोफिल काम करता हूँ। कोरोल्स मींस जस्ट लाइक ए पोरफायरिन्स।
ओके।
तो हम एज ए मेटल, फास्फोरस नॉन मेटल है, लेकिन हम उसको जो कैविटी मोइटीज है, ऑर्गेनिक मोइटी, उसके साथ हम फास्फोरस को ऐड करते हैं वहां पे।
आप फास्फोरस की बात करें कि फास्फर की बात करें, पहले बताइए।
फास्फोरस सर, फास्फोरस।
हमारा वर्किंग फास्फर पे। फास्फर यानी जो मटेरियल लाइट इमिट करता है उसको फास्फर बोलते हैं, और जो आपका केमिस्ट्री का फास्फोरस वो अलग है।
फास्फोरस पी वाला फास्फोरस नहीं सर आपका?
नहीं, जो मटेरियल लाइट इमिट करता है उस मटेरियल को फास्फर बोलते हैं। आप जो फास्फोरस बोल रहे हैं वो केमिस्ट्री का वन ऑफ द एलिमेंट इन द मेलिक प्रोडक्ट है।
एलिमेंट, हाँ, उसको भी हम ऐसे बायोलॉजिकल एप्लीकेशन में जो लाइट इमिटिंग मटेरियल किसी तरह यूज करते हैं सर।
कर सकते हैं, कोई प्रॉब्लम नहीं है।
कंबाइंड विद ऑर्गेनिक मटेरियल, और उसको यूज करके बहुत सेल इमेजिंग एप्लीकेशंस हैं। इसमें आपके एलईडीज में बहुत सारे एप्लीकेशंस उसके ऑलरेडी।
तो आप तो सेंट्रल वाले लोग हैं, और कोई हेल्प हो तो बताइए, गरीब को हम जरूर मदद करेंगे आपकी।
बिल्कुल सर, बिल्कुल। ओके, थैंक यू सर।
वेलकम सर।
सर नमस्कार सर।
नमस्कार नमस्कार सर।
सर इसको हार्टिकल्चर में कैसे यूज करते हैं?
हाँ
हार्टिकल्चर के क्षेत्र में कैसे यूज करते हैं सर?
हाँ करते हैं ना सर, क्यों नहीं करेंगे
सर हाँ सर, किस किस टाइम जो है हर में जो पौधे होते हैं मान लीजिए, जो
हाँ।
प्लांट होते हैं, हाँ तो उसमें किस टाइप इसको हम यूज कर सकते हैं?
तो उसको अगर पौधों को फास्ट बढ़ाना है या उसको फर्टिलाइजर बढ़ाना है
जी
तो रेड एलईडी से एक्सपोज करो, और उसके साथ
जी।
ग्रोथ ज्यादा बढ़ती है और उसका फर्टिलाइजेशन भी बढ़ता है।
तो उसमें कोई पर्टिकुलर प्लांट होता है कि
नहीं
सभी प्लांट के लिए यूज हो सकता है सर?
मैक्सिमम प्लांट के लिए ट्रू है, उसको प्लांट कल्टीवेशन बोलते हैं। तो प्लांट कल्टीवेशन
थैंक यू सर। मैं डॉक्टर प्रकाश दुबे सर, हाँ
या
इटावा से बोल रहे हैं, जनता पीजी कॉलेज।
या
हम हैं फिजिक्स में सर। जी। तो सर बहुत अच्छा लेक्चर लगा आपका, मुझे बहुत बढ़िया लगा।
सर आप बुलाए तो ऑफलाइन में ज्यादा मजा आता है। ये पांडे
ठीक
पांडे
बिल्कुल।
के लिए ऑनलाइन रख के हमारा
हमारा सर एग्रीकल्चर का बड़ा कॉलेज है।
ओके ओके।
हाँ ठीक है।
यस सर, हम आते
थैंक यू
रहेंगे,
सर।
नो प्रॉब्लम। थैंक यू वेरी मच सर।
ठीक।
और पांडे जी कुछ सेवा?
और कोई कुछ बोलना चाहेंगे?
कुछ नहीं सर, एक गला सूख गया तो एक ऑनलाइन टी भेज दीजिएगा।
ठीक, थैंक यू सो मच ढोबले सर। बहुत अच्छा लगा, लोग बहुत अच्छा इंटरेक्शन आपसे किए फिजिक्स के
थैंक यू सर।
इल्यूमिनेशंस के ऊपर में।
आखिर आपका दोस्त हूं ना सर। आपको सभी को बता दो, पांडे सर हम एक साथ हॉस्टल में रहते थे। मेरे बाजू के रूम में पांडे सर रहते थे और हमेशा मुझसे बहुत हेल्प करते थे। पांडे सर यानी बहुत रईस आदमी थे, उस समय बहुत गरीब थे, तो काफी चीजों में वो हमको फाइनेंशियली भी हेल्प करते थे।
समझे कुछ भी। चलो ठीक है, चलिए सबको बहुत बहुत धन्यवाद।
थैंक यू सर। थैंक यू
ढोबले सर, आपका बहुत अच्छा रहा, थैंक यू सो मच।
ओके, थैंक यू सर। लीव हो जाओ सर।
हाँ
ओके।
तो आज का सेशन हम लोग यहीं पर पूरा करते हैं, ठीक है। आज का वीडियो लिंक मैं आप लोगों को भेज दूंगा, और अब हमारा जो कल सेशन, कल से 2 लेक्चर्स होंगे, मैं टाइम टेबल भी आज शाम तक आप लोगों के पास भेज दूंगा, ठीक है ना। आज यहीं पर हम लोग अपना सेशन पूरा करते हैं। सेकेंड हाफ के लिए आपका रिपोर्ट आप तैयार कर लीजिए, और रोज का रोज रिपोर्ट तुरंत तैयार करते जाइएगा, कम से कम पॉइंट्स लिखते जाइए, नहीं तो लास्ट मोमेंट पे बहुत गड़बड़ हो जाती है। सबका वेटिंग पे चला जाता है, सब सोचते हैं आज नहीं तो कल कर लेंगे, परसों कर लेंगे, और फिर वो छूट ही जाता है। तो वो जरूर कर लीजिएगा आप लोग। तो अनुमति लिया जाए।
थैंक यू
सर,
थैंक यू सर।
थैंक यू सर।
कल
ओके, थैंक यू सर।
10:30।
ओके सर।
थैंक यू सर।
10:30। ओके ओके, बाय बाय।
सर सर
हाँ बोलिए। और कुछ
सर कोई फॉर्मेट है क्या बनाने के लिए, यानी क्या क्या कंटेंट होनी चाहिए और कितना पेज का पीडीएफ रहेगा?
कहाँ, कौन पूछ रहे हैं?
आलोक जोशी सर, राजनांदगांव। आलोक कुमार जोशी।
नहीं जोशी सर, आप
जी।
लोग प्रोफेसर हैं, आप लोग जो करके देंगे वही मंजूर है। कोई फॉर्मेट भी नहीं है सर, फॉर्मेट भी आप अपने से बनाइए, सब कुछ सबमिट भी आप अपने से करिए।
ओके, थैंक यू सर।
कोई उसमें ऐसा नहीं।
थैंक यू सर।
और किसी को कोई
Sir,
क्वेश्चन?
please give us today's attendance sheet.
टुडेज
Attendance sheet.
अटेंडेंस मैं अभी व्हाट्सएप पे भेज रहा हूँ।
Okay, sir. Thank you.
व्हाट्सएप में आप लोग सबको ही अपना अटेंडेंस लगा दीजिएगा। जिनका अटेंडेंस नहीं लगेगा, मैं उनको समझूंगा कि वो लोग कोर्स से वो है नहीं। अब ये बात तो सही है ना, अटेंडेंस भेजने के बाद में अगर 62-90 में से 62 लोग तो ऑनलाइन है, अटेंडेंस भी मान लीजिए अगर नहीं आया तो मैं क्या करूंगा, और वो भी ओपन अटेंडेंस है ना। तो मैं आप लोगों को भेजता हूँ फिर, ठीक, अभी भेजता। ओके देन, कल